Guys, today my name is Sheikh Nisar Hussain, and today we are gonna learn how to calculate magnitudes of stars. So first, to start off, magnitude of stars means how bright the star is. For instance, I've got -1, -2, -3, -4, -5, -6. But before that, there will be a variable known as 0. As you see, these are also integers, and as we write 1, 1, 2, wait. As we get till over there, we have to actually write it backwards in this table. Yep. Now it is proper, and yeah. So first, to start off the first subtracted integer variables. For instance, these are the most brightest variables. But over here, on the other hand, we've got the zero. That means yes, it is bright, which you can see with your own naked eye. But as we go over here, the brightness of the stars gets lower. The brightness of stars gets lower the more in the positive integers than the negative integers which we got over here. So for instance, and the difference between them is actually 100. For instance, we've got a star, for example, as you know what? Yeah, let's just take Jupiter for example. So Jupiter's magnitude is 2.5. Jupiter's magnitude is 2.39. So we've got 2.39. Okay. Oh, 1 second. Is it fine if I just write it? No, I'll just do this. So we've got 2.39. Then we have to just get the power, which we will. So how much power do we have over here? So it's actually 2.51. Actually, you can also write it as 2.5, or you can just write 2.51. I like to write as 2.51, so it can be much better. So this variable over here, this number of Jupiter, the magnitude of Jupiter, the first one. Now, for instance, let's just calculate over here. As Jupiter's is minus, we'll take it back over here. So what the difference over here is actually 100. Is just 100 minus. Sorry, it's actually 100 plus. So the more we go over here, for example, the difference is actually 100. Well, our sun's magnitude is actually 27. The brightest we can see in our night sky is actually 27. So now let me ask you a little bit of sums you can do, or I can just continue with my example I've given. So we've got 2. We'll just write off 2.39. Now, well, you don't have to calculate it manually because there might be many errors in this. Instead, I'd like to use a calculator. So what we've got over here is 2.51. Let's just write it up quickly. Wait, I don't think it is written over here. Scientific? Yes. Yeah. So we've got 2.51, 2.51 by the power of. Oh no, I didn't ask for this though. CE 2.51. So we'll just write this. The square at least should be again 2.39. Eh? I don't understand where's the power of symbol. Okay, you know what? Yeah. I'll just calculate and just tell you. Well, actually, Jupiter's magnitude when we write this is actually 6.2 6.3001. Yes. So this is Jupiter's magnitude, and I'll also give you a little bit star example so you can also work out. Just remember the variable which you have to do the power with is 2.51 by the power of, because this is actually greater than 100, so we are obviously going to take this number, or should I say or should I say this. So now we'll just divide it by the power of, because it is greater than 100 times. So as you can see here, and I'll give you some examples. Let's see if you can do that. So these are all the questions I've given. I hope you don't find it too hard, because yeah, this is very less, but it might be a little bit complicated for you. So yep. And if you're all again confused why we use this, let me tell you something. For example, I'll take Sirius. Okay, I'll take a Sirius for example, and this is Sirius A, for instance, and this is Sirius B. Probably right next to Sirius A, as these both are binary stars. Well, how would you know if this star would pass in front of it and would make a difference in magnitude? Well, let me show you. As the star orbits the biggest star, it actually passes in front of our telescopes in a few weeks or in a few months as it changes. So it has no difference. But let me show you something. Now, for instance, we get Sirius. Okay, so as I said, they do a cult in front of each other, and I will show you. 1 second. Yep. So look, as time passes, Sirius B will pass in front of Sirius A. As you can see, it is slowly moving around the star, but it is actually blinking as this is a binary system. Well, let me just speed up time to show you. As you can see, it's getting very close in front of its star. As you can see, look at the magnitude. It's 146. Speed up time just enough. Yeah, it does change. Look, 147. 146 to 147. 148. As you can see, Sirius A and Sirius B's magnitude change in years. So what I'm showing you right now is actually happening nowhere but in oh my god, wait, let me just pause the time. It's now 160:53 from 154. So this is how the changes occur, and this is the beehive cluster. Yeah, actually in India nothing is visible. Anyways, let's move on to our main core subject, what we're looking at. As you saw, as the years pass, a little bit stars just come in front, and right now it's moving. So let's go back to where we were. And as I said, Jupiter also has the magnitude as 2 of 2 in this year. It's something over there like, oh, not bad, but I guess this is in 13,000s. This is how Jupiter was in the 13,000s. Yeah, actually, we're never gonna reach that anyways. No. So as you can see, even Jupiter has its magnitude. Just focus over there. As the planet rotates, the magnitude will change, and in this point as in 2025, the magnitude of Jupiter has increased to 239. Yeah, it has actually increased to 239. Well, actually speed up too much time for Series 8, so yep, it won't show that much. Okay, so let's head back to the magnitudes. And I would kindly recommend if you can write all these questions and you can solve it by your own. If you do not understand, you can actually watch again from the starting and you can understand what I said. Oh, and by the way, the main sum, if you forget, is actually 2.51 or 2.5 by the power of anything you want to write over here. So for instance, we get this 0.50. So what we'll do, we'll just copy this and we are going to come back 0.50. As you can see, we will get this, and our answer approximately will be 1.584343. Or you can just write the answer of this as 1.58 dot dot dot. Yeah, approximately how many numbers there are, you just write the dots. So yeah, done. And if any of you haven't subscribed, please subscribe and like please.